Oh no, I didn't do an intro because I was looking. I was like, why does it say I had the clock off by 1 minute? So we were just talking 1 minute of Spider-Man in the chat. We got to get serious right here. We just wasted 1 minute class time. What are we doing? I had the class off by 1 minute. Brian makes some bold predictions about Tony Stark, Tom Cruise in the movie. I'm just going bold. I'm going bold with those predictions. If I just ruined the new Spider-Man movie, I am sorry. Sorry, 1 minute off on the timer. I don't have my phone next to me right now. I've been using the computer clock. No, if you didn't know, I use a timer, and there it is in the background. And so I had it off by 1 minute. How he wears his Vans in the suit. Tony Stark wearing his Vans in the suit. Love it. So last night, good to see her, Lindsay. Good to see her, Matthew, Whitson, Wilton, Alyssa, Daniel. Good to see everybody. Say hey to some people in the chat. Who attended the activity last night, which is recorded right now? Who attended the activity, which is recorded? It's one of the public videos on the YouTube channel. Does it have 128 views already? Holy mackerel. Wow, it has no likes. I'm going to be the first to like it. If you didn't know, we have the activity posted. Working through it. I'll be watching it tonight. Perfect. That's awesome. Let's go to the main screen and check it out. I wasted 1 minute of class time. Don't tell anybody. I watched it asynchronously. Saved my life. Rachel, I'm so glad. These 50 points go out to Rachel right there. Rachel, thank you so much. I did. It was a great time. But when I did the activity, I will admit I had some trouble with those questions. Yeah. That's the thing is like you can just watch me play scales. You're like, that's easy. I mean, he just played like an F sharp scale. Easy. And then you do it and you're like, oh, this is a little tricky. It's all about that practice. I've been doing this for a long time. It's only going to work for you if you practice. So let's put here activity practice. Now, I want to say people might be worried about this week's assignment. People might be like, this week's assignment, Brian, there's a lot of questions. We're learning a lot right here. We got a lot of notes to get through today. What grade do you need to get on this week's assignment to get a 100? To get a 100 on this week's assignment, what grade do you need on this week's assignment to get a 100? Chat's going to go crazy here and be saying it. So what grade do you need on this week's assignment? An 80. So make sure, don't worry, don't freak out. There's going to be a lot. If you get stuck on something, just be like, I'm just putting that on the shelf. 80 or 16 points. Yeah, and I think it's like I have the rubric down below mentioning. So I guess it is out of 16. Great answer right there, Nathan. Reading the rubric. 20 points right there, Nathan. Great answers. Exactly. So be working on the assignments. I can do some of the assignment during office hours, which I think we've done some of it. Check out the office hours. There'll be some office hours here in a little bit after class. Check out office hours to go through and practice, and even maybe check out some of the 474 stuff we're doing because they get a review of coding also. So you'll see help with 474, and that can help you out. So we are doing the basics of coding in R. Let's put up a little 2 hours later here and get this downloaded. Has anyone been doing any data camp to help out? The only way to learn this stuff, and I'm going to keep saying it. Gosh, I sound like a broken record. The only way to learn this stuff is to practice. You're going to get stuck. You're going to get stuff wrong. But don't worry. Don't worry. That's what I did. When I first started doing coding, I would go to Dr. Petrie, and he would look, and I'd be stuck on something for an hour, and he'd be like, you forgot a comma. Oh, 320, 474, 475, and I have taught other ones. So mainly 201, 320, 474, 475, and then I'll probably start doing capstone here. But yeah, I teach quite a few. 475 is the other one I currently teach. I'm teaching all of them this semester currently. I'm teaching 4 different types of courses. 5 sections, 4 courses. Technically, 6 sections, 5 courses. It's a busy semester, let me just say that. Let's hop back into the notes here. We'll bring down the 2 hours later here in a second. But what you have to do is you can watch me do all of these things, but it comes down to practice. So let's hop over here to the main screen. And we are fighting that internet right now. We are fighting that internet. So Isaiah, we got this. It is recorded. Thank you so much. I appreciate that, Lindsay. Just stay positive. Keep working, and when you get stuck, what is the rule? If you're stuck for more than 5 minutes, ask me a question. I try to reply to as many emails as quickly as I can. I'm eating like lunch and replying to emails. So please ask a question whenever you're stuck, because you can sit there for an hour and just get nothing done. Like let's see, these are all mini functions right here. All of these functions are in the video I posted on my YouTube channel going over basic functions. And all they mainly take is something like x. Like, let's go ahead and take the mean of a vector. So we're going to take the mean of a vector. That's all we're doing right now. This is practicing some basic functions. Let's go over here into R. Let's take the mean of a vector. I'm going to a new R script. Do you have any multiple camera angles or something? Oh, I need to. I do have multiple cameras. I don't have it currently set up. I actually have a GoPro, a little tiny GoPro in my hand right here. Don't have it set up. I need to use OBS Ninja. Need some OBS Ninja. Let's make a vector. How do I make a vector again? Yeah, vector. Great question, Matthew, right here. Let's see. How do we make a vector? And then what is a vector? A vector is like a one-dimensional object, which is just things put in like a line together next to each other. And how do I make one? Great question, Matthew. 20 points. How do I make a vector? How do I make one? There we go. Combined right there. We're going to combine things together into a vector. So let's put into this vector 1, 2, 3, 5, 8. Cool. So now this is like just a line of data. Now it's not 1, 2, 3, 5, 8. It's the value 1, 2, 3, 5, and 8. Does that make sense? What's going? Great job, Max, right there. These are great comments in the chat. I just keep answering questions, keep practicing. Hopefully we have here everybody watching. I hope. How many people are live right now? 33. Oh no, be here live. I know internet's pretty crazy right now, but be here live, be practicing. This is how we learn. This is how we learn. You got to practice. You got to know C combines things together. C stands for combines. It's going to turn it into a vector. What about if I want to do vector, but I only want it to say 5? Now be careful. Here's a trick. How am I going to make the vector only say 5? C stands for basically combined, and then it's like I want to combine this and this and this and this. Joshua, 20 points. Great question right there. I'll just leave it on that. We just want to say I want to combine this with this and this with this and this with this. And we can see down here I've put the vector right here. I'm going to start over. So you can only see that. How could I get to the 5 right here? How could I get to the 5? Diego is right. Now what this is this is pulling positions right here. This is the 4th element. I know it's number 5, but it's the 4th element of a vector. That's got it. And so why does it have to be capitalized? If I type right here, vector, that says object vector not found. Max, another 20 points. Keep asking these questions. Like, this doesn't... Why? Think about why this is not working. And Wilton's right. It won't recognize it. Why? Why does it not recognize it? I mean, I typed vector. What's going on right here? These are the things we just have to practice, and you start to learn that the more you do it, you're like, oh, it's case sensitive, Diego, and other. We're just going crazy with the points. What you can do is you can type 3 letters, and you will get the autocomplete. Use autocomplete. Great job there, Joshua and Megan. Excellent work, and Kevin. It's case sensitive. How about if I type this right here? What will this return? Who knows what this will return? So now this is a sequence of numbers 1 through 3. And so let's change this. Because it's a little boring if we do it that way. So now this will return the positions, the values in the first 3 positions. Diego, great job, Diego. Keep this up. I'm throwing 50 points for all this interaction. Just keep thinking through this. It's returning the positions 1 through 3. Does that make sense? Now let's get a little complicated. You ready? Here we go. Just be practicing and be thinking this through. It's just practice, practice. We have to do as many examples as we can. How do you get the whole code to run right now? Only one will run. It doesn't remember what a vector is. Make sure to hit Control or Command Enter, and then you can run it. Is that making sense right there? Hit Control or Command Enter. Is this working, Daniel? Go to a new R script and then run right here this, and you should see that save in the global environment. So when you hit Control or Command Enter on this line, that runs that and saves it to the global environment. And now we can access what's in the global environment here because that's currently saved. If you don't have this saved to the global environment, because there is no vector, it'll say object vector not found. Daniel, great questions. 20 points, Daniel, or 10 points. It's right there. Why are you using different brackets such as this? These are position brackets. These are amazing questions. These are used for positions. These are used for functions. So Jack right there, great question. If I write a function like mean, so mean is a function. Will I use parentheses or will I use brackets? And to delete things in the global environment, you can go right here, and I'll show you how to delete individual things. If I take the mean of something, will I use parentheses? Because is it a function? Given little hints right here. Or will I use brackets for positions? Since mean is a function, you will use parentheses. So we could take the mean of the vector. Now the vector needs to be stored in the global environment for us to use it. There's the vector stored, and we can take the mean of it. Is this making a little more sense on the brackets right here are for positions? This is saying vector is a numeric object with positions 1 through 5, and then it shows you what's in positions 1 through 5. The parentheses are when you do a function, and you say, we want to take the standard deviation of the vector, and there's the standard deviation. Don't worry about that. That's just a graphics error. Is this making sense when to use parentheses for functions and when to use brackets to take positions? So you could say, what is the standard deviation of elements 3 through 5 of the vector? And that's the standard deviation of elements 3 through 4. Only elements 3 through 4. I said 3 through 5, but I typed 4. Is this making sense if I read this? What is the standard deviation of the vector? Vector is a vector. And only elements 3 through 4. Who thinks they're... Is this making sense how we're using parentheses for functions and brackets are only taking these two elements? So we're only taking those two elements. Can we do mean? Yeah, definitely. Jack right there, Jack. Amazing questions. No, Jack, that was such a good question. You earned the points right there. You're 100% right. You could go here and only take the mean of, let's say, the first 4 elements. Or you could do this, everything but the 5th element. Talking about movies right here. Good, what's his name in the movie? What's his name? Bruce Willis. Bruce Willis, 5th element. Yes, and this is why hashtag show up to class. Whenever you're stuck on something or it doesn't make sense, just ask. Both of these codes right here that I just wrote do the same thing because I'm taking the mean of the vector we have stored here, elements 1 through 4, the mean of the vector with everything but element 5. Yeah, no, the good questions. See, great minds think alike or for themselves. You think along with the great minds and you think, great questions. Look at how much we've learned so far just by asking those questions. So all these little functions we see on the screen are just things you can throw a vector into. All these things right here. Let's head back to the main screen or the teaching screen. You can get the quantiles, you can make a histogram, you can make a box plot, you can get the unique elements, you can get the standard deviation, you can get the min, you can get the max, you can get the median. All of these are functions where you can just input a vector and find out how many elements are in it, the 5-number summary plus the average. All of these will run by just putting in a vector. Now, if there is missingness, how is missingness represented? Someone put a missingness in the chat right now. How is missingness, for 20 points, how is missingness represented inside of R? Who knows how missingness looks inside of R? How would it, if you saw missingness, how would that look? We'll see a bunch of... Nate, great job right there, Veda. And it's capital NA. Great job. Make sure it's capital NA. When you type capital NA, you will see it change colors, which means it's a special reserved character. And let's just look at a few of these special characters. So a special character is something reserved in R that is going to be something used for specific purposes. It's going to be used for specific purposes. So capital NA, now take a look, NA doesn't do this, but things like null, once you type the second L, look how it changes colors. Also, NaN, oh, is it up? See, even I get my capitalization wrong on this. That stands for not a number. So this is missingness. This is a object NA. It'll say object NA not found because it's looking for the object NA over here. This is the what NA. Let's differentiate all of these. This NA right here is what? So line 8 is what is that thing on line 8? So this is good practice knowing, just looking at the colors and stuff like that. That looks reserved. That looks special. That NA right there is missingness. So if you have a vector, what is in position 1? Position 1 is whatting its value. Just think because in position 1 we have capital NA. So in position 1, it's like if there's what? And we can take a look over here. Let's go over here and just call it X. And you can look and there's nothing there. It's missing. Now this is the object NA, which currently does not exist in the global environment because you don't see it here. So it says it's not existing. This is the what NA though. Since it's in quotes, and this is a big thing you should know, since it's in quotes, anything in quotes means it's a what? We talked about this a little last time. It's all about practice. Since it's in quotes, that means it's a character. Shiv, great job right there. 20 points. Shiv, you are correct. That is a character. That's a word, a character, a character string, all those good things. If you're ever wondering what something is, you can always put it inside of class and check what it is by doing this, and it'll tell you it's a character, like a word. CHR. I like that right there. Angela, 20 points. That's the abbreviation we see. And you could also save it to something like Y, and then you should see over here, it doesn't tell you. If we vectorize it, will it tell us? We'll put more than one. We'll put 2 NAs in it. Na 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 na. You gotta make it the song now. How many na na na's are in there? Let's go to rep, which stands for repeat. I think they say it like 20 times. Here we go. We just wrote the lyrics to the My Chemical Romance song. Na 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 na. So there we go. Some old MCR right there for you. But we use the rep function right here to repeat na 20 times. Does that make sense what we've done right here? We made a vector. We didn't actually need to vectorize it. And then he says, I'm not going to write the full lyrics. Give me... Go listen to some MCR after this, My Chemical Romance, if you want. And now we're writing the lyrics right here. There are the lyrics to some MCR right there. Oh my God. This gives some 2000s references. So go check out some MCR. Amazing music. Thank you, Gerard Way. And Frank Iero. Okay, enough about them. And Ray Toro. And I don't know. Oh, and his brother Mikey. Yeah. Okay, we got it. So what are these things down here? What are these? Back on topic. No more MCR for us today. What are these things right here? This null and this NaN are going to be what objects inside of R? Or they're what? Remember I mentioned it earlier because they're a different color. They're what? These things are what? What is that null object and what is that NaN object? Are they class logical? I think it's class null, which means it doesn't have a class. I think null is class null, and null is class null. I don't know what class NaN is. It's a special character. It's class numeric. Oh, because it's not a number, and it's for things that are not a number that are numbers. These are null means that it is nothing. It's nothing. It's not missing. Watch what happens, and I believe this will happen if I go to vector and do null. What did I just do to the vector? Take a look at the vector now. It's gone. So NA is missing. So we could do NA in a character vector where we have right here capital NA, and let's just go here, Brian, Darren. Does it make sense that this is a character vector and the first position is what in this character vector? So now this is a character vector, but the first position is what? This was a numeric vector. This is a character vector. Megan, great questions right here. This is a character vector, and the first position is what? This is a character vector, and the first position is what? When you see this right here, the first position is what? This is still a character. It's missing. Great job right there. It's missing. It's not there. But what happens if I go to the character vector and I do this to it? What will I do to everything? It's like nulling it out. It's Thanos snapping it. What happens if I null it out? What happens then if I store this? It destroys it. It just is gone. So this destroys the positions even. You could take and overwrite the vector with NAs, which would actually create, that made one position of nothing. So now there is a position because the length of this vector, I should have known that. The length of this vector is 1 and there is a missing position. But do it differently right here, just so you can see the small difference. If you take and store into it null, how many positions are there for 50 points? How many positions are there in the character vector now? It's basically non-existent. It's almost like the idea of it exists, but there's no spaces. No, don't do that to Windows 32. Now there is there's nothing inside of it. The idea of it exists, but there's no places to put anything. Positions are just places to put stuff, and it's just like the idea of a characters exists, but there's no places. With the NA right here, there is one place and there's nothing in that place. Think of an egg carton that's empty. Here, I'll make for you an empty egg carton. Let's go here, egg carton. And all I'm going to do here is rep NA 12 times. Here is an empty egg carton. Now, it's a weird egg carton. I can make it probably look more like an egg carton if I do this, because, oh, it's almost so close. Let's try to do a font change. So close. Does anyone see the egg carton, an empty egg carton right here where there's nothing in the positions? I was trying to make it look perfect where it would... It's so close to where you can just see the empty egg carton right here. Does that make sense? You open it up and there's nothing in the positions. But if I do this, if I go here and store null into it, then the idea of an egg carton exists, but we don't even have the positions anymore. It's a little bit odd. It's like we don't have the egg carton, but the idea of an egg carton exists, but there's no positions to store anything. You're just talking about a theoretical thing that is an egg carton, but it doesn't have anything to store in it. It's just like the idea exists of it, but there's no positions to store in anything. Good stuff right there. Little bits, practice. So we're seeing utilizations of these functions. This is exactly what you're seeing me do. Now, I want you to note that if there are NAs, we need an additional what? If a vector has NAs in it, you need an additional what? If a vector has NAs in it, you need an additional what? Every time you see a comma, means we are putting the first this and the second this. If there are NAs, you will get this. Argument right there, Veda, great work. You need an additional argument. And the argument right here is na.remove, or na.rm, which stands for na.remove. Great job right there, Mun and Wilton and Shiv. Great job. So you can find the summary of a vector, the length of a vector, which is how many elements, and everything is summarized here for you. Lots of little things. And lots of people told me this, have your notes out, have the slides out when you're doing the assignments, and use Control or Command F. Who has been working on the assignments and gone up here and done like Command F and been like, okay, let me look up the which function and gone down here to the which function? Has anyone been doing that? Or maybe you're trying to use equals equals and you go search for the equals equals and read about that. Has anyone been doing this when working on their assignment so far by going through and reading about how to do these things right here? Because this is the number one way when you're working on it to use these notes right here is to search through them. Yeah, do that. That's what I hear from a lot of students is like, I just search through the notes for how to do the code and look at the examples. And also ask me for help. When we have factors right here, factors can be summarized into tables. We can get the levels of a factor. What are the levels again? Great job, Daniel, right there. What are the levels of stake preference? When we say levels of a factor is a categorical variable. What are the levels of stake preference? What are the levels? Like if I ran levels stake preference, what would I see appear? Like what are levels? We're just talking about the different answers to the question when we say levels. So a factor is like a variable. A variable is a factor if it's categorical. And so now we're just asking what are the different answers to someone blue rare. Oh man, Matthew. Woo! That's really rare right there. Yeah. Or you got to get that Pittsburgh style right there. So these are the different answers to the question of how would you get your steak cooked? And it's an ordinal categorical variable to be exact. We can turn it into a bar chart, a pie chart, all these great things right here. Lots of really cool functions. So when we summarize it or put it into a table, you'll notice you just get a frequency table. Now on your assignments, you can use this code right here to get a relative frequency table. If your assignment says make a relative frequency table, all we're going to do is take a vector, make a table of it, and then divide by how many elements there are. How can you figure out how long a vector is? Put it in the chat right here. Make sure you're following along for 20 points. How can you figure out how long a vector is? You say, well, what is the length of this vector? I can't speak. Length. The length. Veda got it right there. It is the length. Is the length of a vector. Summary is going to give you output depending on if you give it a numeric or a categorical. Length just tells you how many elements are in that vector. Now I want you to notice something right here. We're not just using a vector. We're using a vector that is inside of a what right now? We'll see more on this. We're using a vector that is inside of a where. Where is this vector inside of? We're using a vector that is inside of a what? I'll highlight it in blue. This is a data frame. We are using a vector right here that is inside of a data frame. Let's go take a look at this in code. So to get to vectors that are inside of data frames, the first thing we're going to do is we're going to use a data frame that is natively in R. Wilton, great job right there, 20 points. Yes. Awesome work. The MT Cars data frame, I'm just going to store as DF. This is a data frame that is like a freebie installed game, like, what is it? Minesweeper. If you have Minesweeper on your computer, it's like free install. This is on your R right now. I'm just storing it as data frame. If you run this code right here, the data frame will appear. All versions of R have this on it. It's just like a pre-installed thing for you. So how do I get to the, I mean, it's giving me hints. How do I get to the, how do I get to those variables? So these are the variables. I can see them right here. And how do I get to these variables? I just clicked on it to look at it. I also opened it up to see the variable names. How can I get to those? What do I type to get to these variables inside of it? How do I get to those variables? I'm like, well, I have the data frame. And how can I get to the variables inside the data frame? It's giving me hints over there. Always use what's on the screen to give you hints. Boom, right there, Veda, another 20 points. You got it. Those dollar signs. Dollar sign's just going to open up the variables. And look, it goes to the autocomplete. Well, then just scroll around. Just be like, okay, I'm going to click enter, and it autocompletes for you. Autocomplete, awesome. So now we can do anything we want this. We can summarize it. We can take the mean of it. We can take the standard deviation of it. We can take the median of it. And these are all little functions right here. We can take the length. We can find out the unique vectors. Or we could even do this. We could go here and go length, unique. And now I've found out what? What did I find out right here? And it actually might be more interesting if I do something like CYL. And what have I found out right here? What have I found out by doing length, unique? So unique gives me the unique values. And then length tells me the length of that vector. How many, great job, Nathan, right there. Perfect. I found out the length of how many unique things there are. So kind of read it. This is the length of how many unique things there are in this vector. So does that make sense if I read it as a sentence, which I try to do a lot? I want the length of how many unique things are inside of this. And so there's 3 unique things. That's what it's telling me. How many unique numbers? Exactly. And it works on other things too. Let me think over here. Do we have any categorical? I think, yeah, iris data set. The iris data set is a data set on flowers. So let's store here iris as df2, just so we can see it over here. Here's data frame 2. And remember, I do post this afterwards. Data frame 2 has species in it. So I'm going to go df2 $species. So if I go here and take this and go unique, here are the unique level of species. Well, how about I just put this inside of length? And the answer is going to be 3 if you can't tell. And now there are 3 unique levels. It says my mean is NA. If you have NA, then you need to add in the second argument right here. Great question. Of NA.remove, and watch it autocomplete. Now click enter and type true. So I'm going to drop this in the chat for you right there. Thank you so much, Jack, right there. Jack, we're dropping this in the chat, and we're throwing Jack 20 points right there for saying something they got stuck on. It looks like you have NAs. If you have NAs, it'll report that it is missing. So you have to use the NA remove equals true as a second argument right here. Jack, great job following along. And this is what you need to be doing, just practicing. If you're following and you're asking questions, hey, Brian, this didn't work. Exactly what you need to be doing. Great job. Any other? I'm going to pause for a moment here. How are people doing? Let's just play a little music and see how everyone's doing. How's everyone doing right now? What are you thinking? I know we're doing a lot. We've already coded 34 lines of code. How is everyone doing? In office hours today, 2 students who are in 474 and just doing, I can say, I don't know. Let's just say I'm really proud of my students, all my students. They mentioned they had never coded anything before 320. That's so awesome to hear, Nathan. And Mun, you're doing a great job. Mun, you're doing a great job answering tons of questions. It's all about that practice. Remember, you only need an 80, and we're just trying to get you some practice in. Yeah, it's just practice. You can watch me play all the scales on the piano and you'd be like, wow, I know how to play every scale. Not until you practice it. So remember, we're just practicing it up. I know it's a lot, right? That's why I slow down here. I'm just gonna take a deep breath. Stretch. Everyone stretch. Stretch break. Stretch break. Is it graded immediately? Not the assignments. Assignments won't be graded immediately. The activity is graded immediately. The assignments are not graded immediately. Data Camp's graded. Data Camp is your best friend. Data Camp's awesome, and they have really great lectures that focus in on just individual things. And I want to say this. Last thing I want to say this. Tiny Brian break. I'm going to make an effect here, working on it.
Advice from Tiny Brian. Okay. People have contacted us who want coders, who want people who are good at this stuff. And if you get really good, there are so many jobs. You're just getting a skill right now. You're getting power. I'm the real powerful one. I'm the villain of this class. Tiny, evil Brian. We need that. So keep working. We need Micro Brian. I'm also Micro Brian. I'm all the Brians. Where's Micro Brian? Oh wait, I don't even know where I'm at. Micro Brian? I'll worry about that later. I can't turn into Micro Brian yet.
Okay. Micro Brian maybe will appear one of these days. I just need to make it like a pure squeaky voice. We do have Giant Brian. We were doing that early. Tiny Brian, Mubot 2024. 50 points. Chat cracking me up as per usual. Good break right there. Let's get back into some coding. Here we go. Time to get back into coding. Time to get serious. Put on that serious face. Fun over. No more fun. If you're having fun right now, cut it out. Cut it out. So sequences. Sequences. Can anyone make a sequence from 1 to 100 really quickly right now? Who can write a sequence in the Ant-Man sequel? I could edit myself into that. I could try. It'd look pretty bad, probably. Who can write a sequence from 1 to 100 really quickly? Who can write a sequence? If I said make a vector 1 to 100. That kind of works. I wouldn't use that. I'd do it the way Veda's doing it. But quicker than just doing sequence 1:100. That does work, I believe. I would just do 1:100. And Whitson's will work also because it'll assume the default right there is by 1. There's lots of examples on this slide of how to do it. Let's do a more complicated one in the chat. Great job, chat, right there, 20 points. I wouldn't do the first argument as 1:100. I would do the way Whitson did it right there. I'm going to copy what Whitson wrote in the chat. The number one way I would do it right now is the way Whitson did it. You could also, so I would do it this way, or I would do it this way. Sequence 100 works. I think so. It assumes a lot of things. The defaults are that it starts usually from 1 to 1 by 1, I think. I think those are the defaults. You can always do question mark SEQ to see the defaults it's using. 1:100 does work, and it will get mad at other times, though. So I wouldn't do that, though. Let me ask you this. How would I write a sequence going from 2 to 50 by 5? How would I write a sequence going from 2 to 50 by 5? How would I write a sequence from 2 to 50 by 5? Length will control how many elements are in it, like how many elements are in your sequence. Yep, and that's the default it will do. What if I want a sequence from 2 to 50, but I only want it to have 2 things in it? So now, great job, chat, right there, 50 points. Great job following them. Now I want a sequence from 2 to 50 with only 2 things in it. I want it to be of length 2, like the sequence has only 2 things in it. From 2 to 50 with only 2 things in it. Now this one's a little more complicated. I want a sequence from 2 to 50 with only 2 things in it. Joshua right there, great job. And Joshua's, and also Wilton, yes, you are correct. Daniel, that also close it off right there and it will work. I think it'll assume that is length. Go ahead and try it in your console to see if it's working, to see if you get a sequence from 2 to 50 with 2 things in it. And the sequence is just 250, like 250. So if you're practicing this right here, Yakui says length 2, exactly. Length is not one of the default arguments. By is the default. So if you do 252 without calling the arguments, you will get a sequence from 2 to 250 by 2. Lots of good examples on the screen here, and just practice, practice, practice. Creating a pattern, we saw the rep earlier. The first thing inside of rep is what do you want to rep? The second thing inside of rep is how many times do you want to rep it? So we get all the zeros. We saw the na 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 na. Gotta count them as I say it so I know how many rep. But right here, you are just repeating something multiple times. This is a rep because you are repeating this sequence right here 5 times. So notice the nested rep right here, where you have the sequence inside of here. I highlighted in yellow. The sequence inside of here, I should have done that in yellow, is the following sequence, which is then repeated 5 times. So you're making a repeat AA, repeat B, 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 and then C, all joined into a vector. And then you are repeating that sequence 5 times. So pretty fun right there. I don't know, just depends if we got to make that sequence. Great job on the points, everybody. The letters vector right here is just a vector of letters. So with this vector of letters right here, you are just taking the letters, like lowercase letters and uppercase letters. I feel like we covered this. I guess we covered it in the other classes. But we are just doing uppercase and lowercase letters. Can anyone tell me how to get the first letter of their name? Like hint, the first letter of my name. I'll put it in the chat right here. Can anyone tell me how to get the first letter of your name? So someone find the first letter of your name in the chat right here. Do you know it? You've kind of got some help right here. If you look at this, you can tell what letter this is of the alphabet. I'm lucky my name is early. I know you already went over this, but my R is only running 1 line at a time. I might need to look at that, Matthew. I might need to look. It will when you do that. Daniel's D right there. You're all right, Daniel. So 13. And then, be careful though. Matthew, I'm throwing you 20 points. Matthew, you used the letters vector as a what though? So good job, Matthew, right there. Good to see it. Matthew, you used the letters vector as a what though? By using parentheses, Matthew is treating the letters vector as though it's a what. We're taking positions on the letters vector, but if you use the parentheses, it'll treat, no, don't worry about that. I'm throwing another 20 points. You would be using it as a function. And these are the practice we need to know that brackets are going to get positions and parentheses are functions. Great job, Emily, right there, and Emery. That's it. You have to keep repeating these things, and the practice makes it a broken record. So here we have the elements of a vector. Once again, you know how to get to some elements. We've been doing this all class today. We have been getting the positions right here. I think we had Dylan up here last class, and he talked about you learn things and it builds. So we can go to position 2 in the vector right here and overwrite it with something. Notice this vector right here, position 2 is 5. If we go to position 2 in the vector and store into it 8, that stands for store into. I wish, right, Jack? Is that another programming language? Is that like Python or C++? Oh, people really hate that R index is at 1, not 0. That's the big problem people have with R when they come from Python. To leave things out, how do we take things out of vectors? Like, how do you remove out positions? So you could remove out a vector of elements, or you could remove out a singular position. How do you remove out singular positions or elements? How do you remove things out? You're like, I want to look at vector X, but not with position 3. Or I want to overwrite vector X with everything but position 3. So this says, take vector X without position 3 and overwrite it into X, or save it into X, which would be overwriting it, because X already exists. So we are creating vector X with elements 2, 5, -6, and 10. We are displaying, printing to the screen, vector X without position 3, because notice that's gone. Then we are using vector X without position 3 and overwriting into X. And then you see, here we are removing out positions 1 and 3, and we are left with just this position because we removed out the other ones. So how do we remove out something from a vector? How do we go into the positions and remove something out? We say, we don't want this thing in here. We just what it out. How do we remove it out for 20 points? How do we take it out? Who knows? How do we remove it out? Max, you're right. We just minus it out. And make sure you're in the positions right there. Make sure to minus it out. I might actually make the extra credits smaller down towards the bottom right on this screen. Changes this weekend that we're going to do. Great job right there, Yakui. Great job. The which function. Now, this one is more complicated. This is where I'm going to just slow it down for a moment. The which function here, when we do the which function, let's go to the main screen. The which function will tell us the positions of the trues. So what if I were to give the which function this? It's going to tell me the position of the true. Great job right there, Joshua. What is which going to give me when I run this? It's going to tell me the position of the true. So just think, what position is that true in? Like, where is it at? It's in position what right now? Where's that at? I can also write it this, which will be the same way. That true is a logical. So what position is that true in? The which is going to take... Great job, Jack, right there, 20 points. The true is in position 1. And how about now? Let's do this, nice and easy. Where is the true at now? So where's the true at now? All the which is going to do is tell me the positions of the trues. And this is something we definitely covered last night with activity. So if you did activity, you're getting lots of practice here. Which tells you the positions of the trues. So it takes a logical vector. This is logical. It's just a vector. To make it even more obvious, I'm just going to call it vector. I'm going to overwrite my vector with vector. Oops, I didn't save it. And now I'm just going to put inside of here vector. And it tells me 1. Still 1, exactly. But what about now? Now you can see the length of the vector is 12. The length of the vector is 12. There's 12 elements. So what will this return when I run it? 50 points if we can figure it out. What will this return when I run it? What will this return when I run it? What will look at the vector. It's got trues and falses. It's going to tell me the positions of the trues. This vector has length 12, and look at where the trues are at. So what will this return? Great job, Joshua, right there. Yep, because those are the positions of the trues, exactly. So it's not returning, I hate that it does that when I do that. I need to rebind these hotkeys. It's returning the positions that there's a true in position 1 and a true in position 12. Does that make sense right there? It's returning a true in position 1. Now, we could make it return even more if we put in more trues in here. You see, wherever there is a true, it's going to tell us where that true is at. Does that make sense? There's a true in position 1, a true in position 5, a true in position 12 right here. And this really is good if I wanted to do something like empty cars, and I wanted to go to the cylinders equals 6, and this would tell me these are the cars that have 6 cylinders, and these are the rows that have cars with 6 cylinders. Does that make sense? Like, if you wanted to look at the empty cars data frame, which we do have stored as DF, we could go right here, and you can see row 1, 2, and 4 have 6-cylinder cars. Does that make sense? What function would you use to count the quantities of entries in a vector? The length. So how many cars have 6 cylinders? I could take this right here, the same code, and I could go here and go length, and I could see 7 cars have 6 cylinders. Does that make sense? There's a lot of ways to do this, though. We could do it with a table, and we could take the same sort of thing and go table, DF, cylinder, and we could get that 7 cars have 6 cylinders. There's a lot of ways to code it. So we just try to practice and know different ways to do it. But does that make sense? This is a table of the cylinders of the cars. This is asking a logical question. Do the cylinders of a car equal to 6? Logically equal to 6. Which cars are they? And then what is the length of the cars that have cylinders equal to 6? On a 1 to 10 scale, still getting object not found, make sure you have run, and I will post this afterwards, make sure you have this run, Daniel. Make sure you run that, and then you can work with the DF I'm working with right here. So make sure you run that right there, and then you should have this. Daniel, 20 points, thanks for asking that right there. That should fix, if you're working with DF, it should then find it right here. So store empty cars into DF. Did that fix it, Daniel? I think that'll fix it, and I will post this afterwards. So that way you can kind of go through and see the different code. Once again, ask me to slow down, like especially when someone says it's not working, I slow down and stop right here. Ooh, yeah. Andy right there. I love that question. Yeah, let me see right here. So if we want to get the false values, so we could figure out the ones that are not equal to 6 by just changing this to not equal to. So this is how many cars do not have it. So you can flip your trues and falses. So the which is going to tell us the positions of the true, and we could go here to not which. And so, well, let me see right here. Which is going to get us the positions of the trues. So you could flip your trues and falses by going around a logical and putting an exclamation mark here. And so that's probably one of the best ways. Such a good question. Thank you, Daniel, right there. But if you put an exclamation mark, like what is exclamation mark true? Really good note right here, Andy. Thank you for asking that. If you want to get the falses, you could just change your trues and falses. So what is exclamation mark true? So if you have any sort of vector, so the which function is supposed to return the true values, it returns the positions of the trues, which returns the positions of things that are true. So you could flip your trues and falses if you want to find the falses. So what is not true? Whenever I see exclamation, it's not. Not true, exactly. So it's false. So if you had a vector right here of something like, like false, 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 true, false, and you wanted to find the positions of the falses, you could go right here and flip it, and then you could go to which. So now this is going to give me the positions of the falses. Does that make sense? So if I want to find the falses, and Andy, such a great question right there, it was really making me think. I flipped them, and I found the ones that are falses by turning my falses into trues. So I'm kind of I'm still finding the trues, but I'm turning all my falses into trues by flipping the whole vector. Andy, we're doing it. We're going straight up right here. Andy, that was a big question of the day. That was worth 100 points right there. Andy, 100-point question of the day. Great question right there. Can you use not with numeric? You can use it. It will flip ones and zeros because ones and zeros are trues and falses. So if you notice right here, 0 is false and not 0 is true. I don't like how it interacts with these. I think it will flip it to I think this will become false. I don't like using it for numbers that are not ones and zeros. So ones and zeros are trues and falses. So literally, if you did, what is the sum of true plus true? Who knows? What is the sum of true plus true? Remember, ones and zeros are trues and falses. Ones and zeros are trues and falses. It's 2. So you can sum that up, or you could take the mean of it, and you'd find out that 100% of that vector is true, or 50% of that vector, if I could spell, is true. Still can't spell. I could just use F. There we go. F in chat. So we have right here 50% of that vector is true. We can figure out the percent of trues very quickly, or we can figure out the percent. Like, let's say you want to find out what percent of cars have 6 cylinders, and you could just take the mean. And these are the percent of cars that have 6 cylinders. Oh, wait, I didn't do the cylinders. The percent of cars that have 6 cylinders is 21.87%. And you could also just times this by 100. Is this making sense right here as I build this? It's all these little bits of code that we're doing and seeing how we can manipulate a logical vector. We can take the mean of it and then multiply everything by 100. How are people feeling? I'm going to pause and slow down here again. What questions are there? I know a lot of people are coding in the background right now and trying these things. Keep trying it on your own. If you make a mistake, don't worry. No one cares if you make mistakes. You have to make mistakes. You have to get it wrong in class to get it right on the test. Looks like everyone's doing well. Lots of questions, lots of answers. Let's go back to the notes here. Let's do this. Where's the notes? I lost the notes. Here we go. So the which tells us the positions of the trues. And what we really need right now is logicals. Now, whenever you see this, you'll hear me say logically equals. Equals equals is logically equals. So what is 2 logically equal to 2? It's a question. 2 logically equal to 2? What will that return in the chat? What will that return if I run 2 logically equal to 2? Is 2 logically equal to 2? True. That is a true statement. 2 is logically equal to 2. Now, this differs from equals because 2 equals 2 will try to assign. It's the same thing as doing a left arrow. It'll try to assign 2 into 2, which can't be done. How about percent I in percent, though? Percent I in percent is asking, is 2 contained over here? And the answer is yes for this. But let's look at this. Is 2 logically equal to 1, 2? Is 2 contained in percent I in percent the vector 1, 2? So focusing in on that first question, yep, great job right there, Jack. Awesome job running that right there. Get those errors, see how they work, and we can't store a 2 into a 2. So with this right here, what will the top code return? Who knows what this top code right here will return? Is 2 logically equal to 1, 2? which is actually two questions. Is 2 logically equal to 1? Is 2 logically equal to 2? What does that code right there return? Try running it. It returns true, false, or false, true, false, true. Because 2 is not logically equal to 1. 2 is logically equal to 2. Now, the next question is different, though. Is 2 contained over here? Just think of it as a sentence as I read it. Is 2 contained over here? For this one, is 2 contained over here? True or false? 2 is contained over here. That is just true. Because all we're doing is saying is 2 contained over here. But on the first one, we said is 2 equal to this, false, is 2 equal to this, true. So contained in just sees if the thing on the left is an element of the thing on the right. And we have some examples coming up here showing it. Other ones right here, is NA. Check to see if things is NA. You can see if something is not missing. This is just, is it missing? Is it not missing? What are the positions of things that are missing? What are the positions of things that are not missing? Using a which, we'll get the positions of the things that meet the logical condition. We have other ones like not equal to. So instead of equals, not equals. Remember, the not right here is exclamation. Big note on that. So some examples. We're first talking about the ands and the ors. If you have two logical statements, you can combine them with ands and ors. Who knows what this would be? True and true. True and true would be what? If we say true and true, that would be what? True and true. The first one is true and the second one is true. So this right here would evaluate to true. How about true and false? True and false evaluates to false. Everything has to be true in a and for it to return true. What about true or false? When you have or, there needs to be only one true. So when we use the or condition, it can be equal to or less than 0, or equal to 2, or missing. And as long as one of those is met, it will return the value. But if you have and, you have to meet every condition for it to be returned. So with the and right here, we're only getting values that are greater than or equal to 0 and less than or equal to 4. So that's going to be between the values. It has to be greater than or equal to 0 and less than or equal to 4. This could be any of these. It can be this or this or this. As long as it meets one of those, it will return right here. So important is to know this right here, that if you connect with an and, everything must be true. If you connect with an or, only one of them needs to be true. Good stuff. And I think the percent and percent is next. Yes. Lots of examples right here. It's a pipe. So where is that on your keyboard? Whoops. On your keyboard, under the backspace, it's under backspace. It's called pipe. Got it? Yep. It's the or. Yep. And that's a pipe underneath the backspace on your keyboard. That thing right there is a pipe, they call it. So great questions, Jack. Great questions right there. Thank you for asking. And Wilton, I'm throwing some 50 points. Wilton answering some questions in the chat. I love it when people are answering and asking questions. That's what we need. And right here, instead of writing to x is equal to 1, 2, 3, 4, 5, or 6 using the ors, we can see if x is contained in these values. So is the value of x contained in these values? Not is x 1 or 2 or 5 or 12. Is the value of x contained in these values? And take a look. What do we get? We get only, since we put inside of here a which, only the positions of things. Position 1, position 2, position 4, and position 8, which are values of x that are contained in the vector 1, 2, 5, and 12. There's no 12. But with this right here, you can see how the which is being used to return the positions of the things that meet the conditions of x being contained in the vector 1, 2, 5, 12. Once again, these notes are a very good help. Let me ask you this. Let's only focus on this code right here. What will this code return for you? Only this. Only this which I've underlined. Take a look right here. It's going to look for and do a logical test to see if x is what, and then you're going to get the what's of those things. So this right here is going to do a logical test. So explain what this code, just this portion I've underlined. So what is this going to do right here? Just the logical test, and then the which is going to turn it into what's, because this will return back trues and falses. That returns back trues and falses. And then this will tell you the what's of the what's. The positions of the x's that are less than or equal to 5 exactly. And then by putting it inside of the brackets, we can return back the values in the positions. Does that make sense, Wilton, right here? Here's the values of the things that are in the positions that meet the logical conditions. So these are the positions, as Matthew's pointing out. Matthew, great job right there. I love it. People come in, they're like, hey, Brian, it's a lot. And now you're reading it. You're saying, okay, this is a logical test to see if things are less than or equal to 5. This gets us the positions. And then this returns back from the vector x the things that are in the positions which meet the conditions. I did this and I got an error. Make sure you've loaded in x. So here, let me highlight this in the chat. Unexpected. Ooh, you might need to show me that. Run this. Gets us to the values of the positions. Ah, yes. So let me explain that right here. Thank you so much right there, Max. I think I asked that. Max, great questions. So the square brackets, I'll show it on another screen. So whenever you use square brackets, do I have an x stored in here? I don't have an x. Do I have a capital X? Oh, here, let's just do x is a vector of 1 to 100. And if I go here and I say x, let's say, is contained in, x is contained in the vector of 5, 80. So now if you look, does it make sense that it's telling me that this is something that is 80? So when I run this right here, which, and I'm going to make this a little more interesting by making it start at 3. So it starts at 3, and we run this right here, and we run the which on it. Running the which will tell me the what's of these things. So now I have the vector 3 through 100, and running the which on this, it tells me the what's of this, where the what's are at. Oh, that's all right, Jack, no worries. Running the which tells me the what's of the what's. Running the which tells me the what of the what, the positions of the trues, exactly. Now I'm going to go to my vector x, and since these are positions right here, it's just positions, I'm just going to return back those positions, and it returns back this, because it says return back the things that are in position 3 and position 78, which are the values of 5 and 80, because I said I want the things that are 5 and 80 from the vector x. Does that make more sense, Max? This is just positions right here. This is literally the same thing as putting right here a vector of positions, because that's what it stands for. Like, this is that right here. I know we're seeing a lot of different numbers. Max sees it. Max, some 50 points right there. Getting tons of points. It's that practice. Yep. It helps out a lot because you could go right here and you could go to... I don't want to pull it up yet. I don't want to do too many examples. Slow it down here. Slow it down. I get too excited and want to do a bunch of coding. So with factors right here, note on selecting elements of a factor. Yeah, make sure to put it in quotes. Very good thing right here to know that when you're using factors, you want to put it in quotes. So be very careful. Put your factors in quotes. Dr. Petrie, you're hilarious with your words right there. The subset function. When we are using the subset function will allow us to either subset vectors or data frames. The first argument is we subsetting. It does say name of vector, but the first argument is what are we subsetting? And the second argument is what is our condition for subsetting? So we see it with some vectors here at the start. So you could easily take a vector, and here's the vector you're subsetting, and you're just asking, give me only the elements that are greater than or equal to greater than 5. I want to subset x, and I want only the values of x that are contained in 1 through 5. Here we are with a factor. I want to subset x, and I want only the values of x that are equal to a, make sure it's in quote, or the values of x that are equal to b. We could say a or b, or a and b, but we wouldn't get anything. How is everyone doing on this right here? That subset takes 2 arguments, and the first argument is, what are we subsetting? And then the second argument is, what is the condition we're subsetting on? Let's look at an example while people think this over. Let's do it with a data frame here, which is one of the next things we're going to get to. Remember how we have this iris data frame? The iris data frame has in it different types of flowers. What if I only want these flowers? I would call the subset function right here, and the first argument is going to be what? I'm going to pause, Because think the first argument is going to be what? My first argument is what do I want to subset? So what do I want to subset right here? I want to subset the what data frame. So what do I want to subset? Remember, the first argument is what do you want to subset? So what should I put there? Iris, great job. Lowercase. A lot of times we use uppercase for data frames. This time it's not an uppercase, but it is lowercase this time. So the Iris data frame. Now we're going to put a comma, which means a new argument. Now the question is, well, what conditions do I want? Well, I want to subset the species and make sure it's in quotes where only it's that. And I copy pasted. Copy paste is your best friend also. And take a look. My subset, which I'm going to store into sub, only contains flowers that have species something. We can check by going here and looking at the species, and they're all that type of flower right there. Virginicea. Don't know how to say that. So we have only taken these flowers. What about if we did this? Or, where's my or? See, even I can't find the pipe. So we have or, and let's look at the species again, or Cetasoa, and we'll do this right here. That should do it. Oh, no, we have to do this still. I was going to make an error. So now we have it is subset species this or this. And don't worry about that. That's just a graphics error. And now if you look, we have 100 flowers. So we have subsetted that the species is this or this. Does this make sense that this is the conditions right here? I say I want species equals to this or equals to this. I could ask things additionally about like petal width. Can you copy the function you wrote? Of course. Feel free to say, hey, Brian, can you copy paste that? There you go. There's the subset right there in the chat. You got it. Great questions right there, Jack. Definitely. That is how we do that right there. We will continue on. Keep asking those questions. Subset function on the way right there. Let's go back. Tables are named vectors. So when you have a table right here, you can actually call either the position or the name of it. So when you make a table, we use categorical variables, and you will get the names at the top. So right here, you can see the different elements of it. And going through, it's a lot on the screen. I've never liked how complicated this makes it look. Why not make it look really easy? So let's make a table and see how it's a named vector. My least favorite slides right there. How about this? Table, iris, and species. So watch this. Let's store this into X. Who knows what the class of X is? Who knows what the class of X is? There's a hint on the screen. Who knows what the class of X is? So this class, it's a named vector because it's also this. X, looking at what it is, which is part of your assignment to know how to identify how R sees things. X is a what? It's not a data frame. It's actually, great job right there, Whitson, good guess. It's actually just a table.
Wow.
So it's a table, and a table is a named vector. So let's go here, and it does have integer values. Great job right there, Mun, looking at it. It's got integer values inside the table. It's a table of integer values. Let's go here and go to position 1, and we see Cetasoa 50. But when we say it's a named vector, the positions have names to them. So notice how this command right here and this command right here return the same thing. A named vector allows you to use the names on top of the vectors to call the positions. So does this make sense? How could I go to Virginicea and go to table X and get Virginicea without having to type Virginicea? I can see it. I could type it. But how could I go there without putting this in here like this? How could I get to that without, well, whoops. How could I do that? Because we can just call the position or we can call the name of the position. How can we do that? We've got a vector right there. It's got 3 elements in it. And how could we go to Virginicea position? We can call it, yep, we can do this or this. It'll do the same thing because it's just a named vector. Named vector right there. And that's what we're seeing across here. Just a lot of different things showing the names of the table, all this stuff. I cheated. Oh, you're doing a great job. You're doing it. You are practicing. Growing and appending vectors. You can store 2 positions in vectors, especially things that don't exist. If you write to a vector, it'll append onto it to positions. If you go beyond the positions that exist in a vector, you will get whatness. We got 10 more minutes and we got time for more slides. If you write to things that don't exist in vectors, you will get whatness. If you write to things that don't exist in vectors, like if you write to position 12 and there's no position 9, 10, and 11, you'll get missingness, 20 points. You'll get missingness. So we just write to positions in vectors by storing into them. And you can grow vectors. You can remove from vectors. What symbol would you put to delete something from a vector? Once again, this is more review. What are you going to do to remove a position from a vector? If you're just like, I don't want this in my vector anymore. Let me just remove this position out of a vector. How would you remove a position out of a vector? Minus. Just delete it out. Operations on vectors. We don't really use this in our assignments, so don't worry about it. Equally sized vectors, you'll get warnings if you're not using equally sized vectors. If I'm going a little bit quickly through these notes, it's because they go more in depth than we need right now, and I'm going to get us to data frames because that's going to be super important for the assignment. Adding levels to a factor. When you work with factors, you actually have to write to the levels vector. We are whatting the levels vector right here by using this code. This code right here is combining the levels vector along with the level fish. So we are growing the levels vector and adding a new level to the levels vector. Who remembers what levels are for a factor? Levels for a factor, like right now, the levels of this factor are dog, 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 cat, 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 dog, which it's actually just cat and dog. The levels, which are for a categorical variable, which are factors, are just the different what's for the question. The levels are just the different what's. All the levels are the different types of what's we have for a categorical question. The different answers, the different responses, exactly. Great job right there, Megan, 20 points. The different answers, the different responses are the different levels. So if you look at the levels, you can see the different responses that are possible for a question. And you have to make that level exist to be able to create that level. When we want to rename levels, and this is the coolest thing ever. I showed this to 474 this morning and it blew their mind. Take a look at this. You ready? Let's go back to the main screen. I don't like how these levels look for the iris data frame. If you look at all the names of the species, this is too long. We've got here Cetaceoa, Versia. So let me do this. Let me go to the levels and watch this. I'm going to overwrite this with S. Whoops, I need to put in quotes. Almost made a mistake. I'm going to write this with S, V1, and V2. Now, it's a little bit coded now, but check this out. Now, when we go back and look at the vector, guess what I just did? I just recoded every single observation in the data frame. If you go look at the data frame, I recoded every single one of these. So no need to copy paste. It's that quick with coding, and that's why we like coding. By running this code right here, I went to the levels vector, which is just, I know, right? It's like, oh, just recoded it. It doesn't matter how many entries you have. Actually, we have way bigger data sets. Like, let me go to a way bigger data set, which, where is it? It's the retailer data set, right? Let me go to the retailer data set. You don't have this one. Retailer data set has a lot of observations. So if you notice right here, do we not have any categorical ones? Ooh, product. It's a character vector. So retailer data set. How do I spell retailer? Retailer. There we go. Retailer data set, product. Those are all the products. Let's turn it into a factor. And let's look at it. How many levels does it have? Actually, we can get there's 30 levels. This would be a fun one to work with. There are 30 levels to this. And we could go here to the names of the factor. And wait, we want to go to levels. Sorry, what's on there? There's the levels. And you could recode this. So these are all the different answers to the question right here. And you could just recode it. I could go here to the first level and just recode this as BA. And then, oh, did I already wreck it? Maybe. No found. I'll fix it another time. But we can go ahead and recode stuff. Could not find function factor. I'll work on that another time. How would you rename the table itself? Asking for a friend. Rename the table? Like rename Iris? If you want to rename Iris, you can just overwrite it into something else like random name here. And you can overwrite it into that. And you have now created your own table. Does that make sense? Good question right there, Whitson. We can just overwrite it into anything we want right there. So there's lots of options, endless options. You can just overwrite. We've got right here dealing with factors, changing levels, the column. Oh, if you want to, let's do that real quick. Let me show that. You want to change the name of a column. If you want to change the name of a column in the Iris data frame, let's go to the Iris data frame, or let's go to DF. So if I go here and I go to the names, which are the column names, now I go to names 1 and I go to miles per gallon. Take a look right up here. What do you notice happened? I went to the names, which are the column names, and I overwrote it as miles per gallon. So I went to, does that make sense, Whitson, right there? Whitson, 50 points. Thank you so much for asking that question. I got to rechange the buttons. But does that make sense what I did? I went to the names vector. I went to the first position, which is here, and I overwrote the names vector. Let's talk a little bit about data frames to end, because we're almost out of time. When it comes to data frames have what inside of them? How do you add a column? Ooh, I think people are asking questions for the class. What if we wanted to add a column to this? We could just store to something that does not exist. How about new column? Do you notice how the autocomplete is not kicking in right now? There's no autocomplete. Why is autocomplete not doing anything right here? Why is autocomplete not showing anything when I do this? So when I type new column, it doesn't show up. What's going on right there when autocomplete's not working? Why is new column not showing up? New column is not showing up because it doesn't exist. Maybe I want new column to be a bunch of missingness. Now take a look. New column right here exists. No, ours not broken. New column exists now, and it's just a bunch of missingness. We could do other things like take and do a ratio of the miles per gallon to the cylinders, and we have just now created a ratio. Maybe we should call that ratio MPG to cylinders. And now we've created a column called ratio MPG to cylinder. But you know this new column thing? I don't want it to exist. So let me go to new column and destroy it, and it's gone. How's that looking right there, and is it making some more sense? The biggest thing, and we've got just a minute more to go, is that you have to practice, and you have to ask these questions. And Wilton, great job right there. Is it making some more sense? Data frames are two-dimensional. And in a two-dimensional data frame, we'll have inside of it rows, and we'll have inside of it columns. So Brian, right now you are going to the where and returning the what in the data frame. What is Brian returning currently in this data frame? Take a look. Last question worth 50 points right here. Brian is returning the 1 in this data frame, the value in this data frame right here that is in the where. It's two-dimensional because it looks like this. And you can see the answer to the question. I'm returning the what. So take a look at this right here. 35 seconds to go, it says, oh no, what am I returning? The second row, the second column, and remember it's rows and columns. How about this? Now we're returning everything in row 1 through 5 for the second column. How about this? Now we're returning everything in row 1 through 5 for columns 1 and 2. And it starts to look like a data frame again because we have rows 1 through 5, columns 1 and 2. And last question I'll ask, because time's going to run out here right away. How about if I do this? This is the data frame, rows 1 through 5, everything but column 2. And column 2 was cylinder, and notice how cylinder is missing. And that's got it. That's the end of class. We'll pick up here next time, kind of reviewing more data frame stuff. But how are people doing on the assignment? Who's been working on the assignment in the background, and how do you feel? I know it's a bit. Remember, you only need an 80. And the biggest thing is practicing. Activity night, I think, got people off to a good start. How do people feel about the assignment? Let me know. We'll put on a little music right here. How are people feeling? Whew. It's funny. We do so much, and then I'm sometimes like, we didn't do enough. We need to do more. We need to learn. Feeling okay, I like it. I ended class on time, right? Yes, I know when class ends. There was one time I ended class like 10 minutes early, and everyone's like, class is still going. And everyone's like, no, don't tell them that. Start on time, end on time. Best place to ask questions on the assignment is Discord, right? Yes, I love it when people ask questions on the Discord. Do we have Kahoots for this class? Yep, I think we're going to start having Kahoots next week. I'm going to try to have a big, huge Kahoot. I'm going to try to get some guest appearances. I tell you this right now, I'd really love to have Dave Ramsey come on here and give some like pep talk to my students. If I could have Dave Ramsey appear and maybe talk about a little financial advice. Here's life advice with Brian. Life advice with Brian. If you can find a way to save, let's just think about it, $5 a week. I mean, it's rather simple mathematics. But think about this. While you're in college, if you spend 4 years if you spend 5.5 years like Brian, that's 52 weeks a year. So you'll spend 286 weeks. You know what we could do? We could store weeks right here in college. Week in a year. Well, let's go here. Weeks, 52. Years, 4. And let's say money saved. If you can figure out a way to save $10 a week, then if we go right here and we just take, and weeks are always 52. So if we go right here and we go to total equals money saved times years, weeks, and you will save a total of $2,000 if you can save $10 a week. No credit card right there. Yeah. I use a credit card, but I heard good advice on that. Like when you spend money and it's not on a credit card, it hurts. Like you got to hand over that $100 bill and you're like, oh, that's $100. When you spend a credit card, you're like, oh, that's $100. If you could save $50 a week, which would be insane, which don't, I'm not saying save that much. Don't do that. If you would save that much money, you'd save $10,000. It's a lot of money. But the small things, like a Starbucks coffee versus drinking a Keurig, how much money do you save if you drink from who has a Keurig, and how much money do you save if you just drink from your Keurig one time instead of your Starbucks? How much money would you save drinking a cup of Keurig coffee versus a cup of Starbucks? How much money do you think you would save? Put your bills on a card and get the cash back on. Yeah, I think that's really good. Mun's giving some good advice right here. $5. So the Keurig is like 50 cents. So if you do that twice a week, if you say, okay, you know what? I drink, maybe right now, like maybe you're an everyday Starbucks person. If you are in 30 cents, so that's $4.70. That's $9.40 for the Keurig. If you are a if you're a 5-day a week Starbucks person, and I'm not saying enjoy your life, have fun. This is life advice with Brian once again. If you are a 5-day a week Starbucks person, if you say, I'm going to now make it twice a week, I'm going to drink my Keurig, well, then you will save $10,000 up. Whoops, not 10,000, 2,000. Whoops, don't be very careful. $2,000. You will save $2,000. And yeah, but maybe you say that's not worth it, Brian. Maybe you'd say, I prefer to just drink my Starbucks. Perfectly fine. I think making these small changes right here are what start to add up. You just find little things and make changes, because the more money you can save and the better you can plan out and the better you can figure out, just how to live under, like, I don't know. I'm giving too much life advice. I don't know. I got hooked on my Keurig and now I've got good cream. The cream's probably the most expensive thing. Great value K-Cups are like 30 cents. Yeah, Kevin, that's such good advice right there. I drink I get ours for like 35 cents a cup. But Starbucks, that pumpkin spice latte, I'm not going to lie. Like a big pumpkin spice latte, I should get one and split it with Chelsea. Now I want a pumpkin spice latte. $2,000 in a NASDAQ ETF is throwing 10% returns right now. Wow. So you could probably save even more money if you started investing it while in college. But just itemize how you have. And I'll say this much right now. Like my last little life advice is, especially with current world situation, I've found out the hard way that, I've known this for a long time. Money doesn't make you happy. It's being able to see like family, friends, and those things that make you happy. So, money I think can cause a lot of pain when you don't have it, but you're not going to be super happy just spending a bunch of money. Like if you had a whole bunch of money you could spend, it's not going to make you happy if you're not happy. So it's the weird thing that literally having money doesn't create happiness, but lacking money creates sadness. So it's almost like having money can help with not having some sadness. It just makes life harder if you don't have the funds. So I think the best thing to do is to start out, like as Mun's saying right there, with responsible decisions. And Mun, you're probably more responsible than me by only having a credit card for bills. I still use a card for purchases, which if we ever speak to Dave Ramsey, he'll probably tell me I'm a fool. But yeah. Anyways, any last questions for me right here? Any last questions? Oh, these are the real world things. Let's go look. I think I have office hours here in 20 minutes or 13 minutes. Office hours coming up. Let's go to the main screen. Remember, check out the activity from last night. You'll see a lot more practice. So check out the activity, a lot more practice. We went through every single question. You can watch me code everything. I can read off all the notes. I could go through every single note and then you'd be like, none of it makes sense. The more you practice, the better you understand it. And that's what it takes. Practice, practice, practice. I want to make custom emojis for our channel, but I think I have to put memberships, and I want to put memberships. It's a bummer. With that, everybody, we will be back. Swing by office hours if you have questions. Is all good. I use my credit card to buy stuff too. Oh, that's Mun. You're like me then. It's totally fine. Personally, I think it's all right to use a credit card, but I'll say this much: I didn't use one responsibly my whole life, so maybe I should take advice. You're welcome. Oh, I'm so glad, Mun. And lots of people are watching it, looks like. So we'll keep doing them throughout the week. We're going to start having some Kahoots. You have to pay for Kahoots now. Speaking of money. Anyways, we'll be back here soon. Bye for now, everyone. Bye.